What's happening, dogs? Mr. Allen here with some super fun circle problems here. We got to do some algebra within geometry. I love it. So we're going to set up an algebraic equation based on properties of geometry, in this case, circles. All right, first one here, we are given circle A. So my center of that circle is A. That's all I've got, right? But let's think here. BC passes through the center. That makes this guy a diameter, right? Which would make this a semicircle and this a semicircle. Well, did you know that if a triangle is inscribed in a semicircle, it has to be a right triangle, meaning 8x minus 6 has to equal 90 degrees because it's a right angle. Now, if you don't believe me on the whole inscribing of a triangle, check this out. This arc right here, that's a semicircle, right? It's 180 degrees. Well, angle D right over here is an on angle or an inscribed angle. The angle has been inscribed in the circle because its vertex is on the edge of that circle. It is half the measure of the arc that it intercepts. And in this case, angle D here, boom, hits at B and C. It intercepts this arc right here. Half of 180 is 90 degrees. So either way you slice it, that's going to be 90 degrees. So now we just got a two-step equation, right? I'm going to add 6, not 9, 6, there we go. I get 8x equals 96. And if I divide by 8 on both sides, I get x equals 12. Beautiful. Nice. And it's always good to check in geometry for what's called extraneous solutions to make sure that it works in the original. I would have 8 times 12 is 96, minus 6 is 90, right? It's all good. Usually you'll get some red flags if you get like 2 solutions. There's potential for both of them to work. But there are times where only one of them works. You do want to make sure that you get like a positive, I don't know why I'm putting quotes around that. You want to get a positive answer, a positive angle measure, a positive segment length, a positive area, right? I don't care if x is necessarily negative. It can still work if x is negative, but it's got to give you a positive angle measure, positive length, positive area, volume, so on and so forth, okay? Always check for those things in geometry. Next problem, circle D, and we have the measure of angle C is 30 degrees. And I got to solve for x right here. That's a central angle. How the heck am I supposed to do that? Well, again, we have ourselves an inscribed angle, right? That vertex is on the circle. Some call it an on angle. Some call it an inscribed angle. Depends on the lingo that your teacher's using. Anywho, an on angle is half of the arc that it intercepts. Well, C goes out to A and B. So C is half the measure of this arc. Could I reverse that? Heck yeah, I can multiply 30 by 2 and I get 60 degrees for that arc. What do I know about central angles and their intercepted arc? Because D intercepts arc AB as well. Well, the central angle is equal to the intercepted arc. Perfect. I can set something up with that. 5x plus 15 is equal to 60. I'm going to subtract 15, so I get 5x equals 45. Then I'll divide by 5. I get x equals 9. Nice. There we go, man. 2 problems in the bank, baby. All right, so we can give you these things in different iterations, right? We could have just given you flat out the arc there and you had to solve for that one. We could have given you the arc and you got to solve like algebraically for something right down here. So be thinking about all those different possibilities and being able to use your properties of these angles. Central angle equals the arc. The on angle or the inscribed angle is equal to half the measure of that intercepted arc. And this bad boy right here is actually super applicable, okay, in real life too. I've done some dope math in the wilds with triangles that are inscribed in a circle, right, or in a semicircle rather, that are right angles, because right angles are super important in the wild. All right, that's about it for this one. Have an awesome day, you guys, and keep on mathin'.